All right, the goal of this lab is to determine the acceleration due to gravity by analyzing a video that you record. So on the screen here, I've got a video shown that I recorded, and you're going to record something like this. You're going to be dropping an object of your choice from some height, and you're going to make sure that you have something like a meter stick that you can use for reference. It doesn't have to be a meter stick. It can be any object that you know the length of. A couple of things to note about this video. I have recorded it sideways. I have kept the video stable as I recorded it, so it's not moving, the camera's not moving, and I recorded the clip of my object falling freely. So this is a video that I'm downloading, and I'm going to analyze this video in Logger Pro. So open up Logger Pro, and it should look something like this. On the left axis, you've got the Y, and on the other axis, you've got X, but this will all change when you import a video. So how do we import a video? We are going to be using the Analyze menu, but to insert the video, we actually go over to the next menu option, Insert, and down there it says Movie. Here's where you insert the movie that you recorded. It'll probably go into the Downloads folder, so you can open the file from here, and it's going to pop up on the screen. There's some playback buttons in the lower left-hand corner. You can hit play, you can hit stop, and what I'm trying to do is I'm trying to position the playhead to the moment right before I release the ball. So I'm moving this to the place where I can see that the ball is still stationary, it hasn't moved, and this is where I'm going to start collecting my data. Now, before you can collect data, there's something you need to do, and you're going to click in the lower right-hand corner where you see 3 dots and a triangle, and there are 3 things we need to do to analyze this video. We're going to use these 3 buttons. First button is to set the scale. This is the yellow ruler, and it's the yellow ruler without the arrows. You've got the set origin and add points. So, step 1, we're going to set the scale, not the one with the red arrows. Set the scale. So, to set the scale, all you need to do is drag a line from one end of your object to the other end of the object. And this is going to default to 1 meter, which is the length of our object. If it's not 1 meter, you could just enter the known size of that object. And we click OK. So that sets the scale so that the video now knows what's the length of this object. Second step is we need to define the origin. So click this green Set Origin button. So this is going to allow us to define where is 0, 0. X equals 0, Y equals 0. I'm going to define that right in the center of my ball. So I'll click in the center of the ball, and that creates this axis where I'm defining the origin. Third step is to collect our data. So it says add point, and I'm just going to check under options, my movie options, and I'm going to verify that the frame rate is what I want. All right, it says frame rate is 29.79. That's good. That's the default frame rate of my video. If you did it in slow motion, you would need to change it to the frame rate of your slow motion. But I recommend for this one to just leave it not as slow motion. Okay, so we're ready to collect our data points. Every time I click on the ball, it adds a data point. And I'm clicking in the same location because in these first several seconds of the video, the ball isn't moving. So I'm clicking in the same position. Now my goal is to click on the position of the ball at each moment of time. And each time I click, the video advances by itself. So the ball is getting a little bit blurry, but my goal is just to pick a location on that ball that has a consistent blur, I guess I could say. So I'm trying to click in the middle of the blur. Now I could have that be my last click, but I'm going to choose to continue clicking just because it'll make a more interesting graph. And I'm going to continue clicking in the middle of the blur to track the position of this ball as it changes over time. And every time I click, the frame advances. Okay, so the ball reaches the top of its path in the bounce, starts to go back down. I keep clicking in the center of the ball or the center of the blur, and it goes down and down and down. I'm going to make my last click here before it hits the ground, and now I can see my data. So on Logger Pro, I can see two graphs, a blue graph and a red graph. On the left, it says that in blue, it's showing my vertical position, and in red, we've got my horizontal position. So that's on the y-axis, and the x-axis is showing time. So in blue, I can see this nice curved shape where I have my acceleration due to gravity, and then it bounces, and then it curves again. Again, acceleration due to gravity. And in red, I've got some points going down. It's got a negative slope, a negative velocity, which just tells me that the ball is moving from the right to the left, where left is defined as the negative direction. All right, so what do we do next? I'm going to take a screenshot to show my experimental setup. This is something I'm going to use in my lab report to document how I calibrated the video. And now I can click over on the left, and if you just click the title, you can choose what you want to display. All I'm really concerned about in this lab is the vertical position versus time. And here I have my curved lines again, where I can see that acceleration due to gravity happening. All right, so my goal is to find the change in velocity over change in time. How do I do that? All right, you saw that I just clicked again, and I switched the axis to y velocity. So for the first 0.5 seconds of this video, my velocity remains at 0, so I haven't released the ball. Then at this time, I release the ball, and it starts to go faster and faster and faster in the negative direction. So it's going down, 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 faster and faster and faster. At this point, it bounces at the bottom, and its velocity is going to change rapidly. It changes from a negative velocity in the downwards direction to a positive velocity in the upwards direction. And then it starts to decrease velocity again. So it was going fast in the upwards direction, and then it hits its peak right here at velocity 0, and then it starts to go faster and faster in the negative direction. And my challenge now is to find the slope, recalling that acceleration is the change in velocity divided by change in time. All right, here's the key part of the lab. How do I find acceleration? Well, I want to find the slope of this line. If I select by highlighting the region and then click on this icon that says linear fit, the linear fit will bring up the equation of that section of the graph. And I can see that the slope of this graph was negative 11.26 meters per second, or meters per second squared. I'll take a screenshot of this for my lab report. And I am also going to just check out the acceleration in this second region as the ball after the bounce. Now I would expect that this is also the acceleration due to gravity. And I see that this has a value of negative 10.41 meters per second squared. All right, last step. I need to analyze this data, take a screenshot from my lab report, and I'm going to analyze these two numbers. Now, I would expect that the acceleration due to gravity is negative 9.81 meters per second squared. But neither of these results matches that exactly. So now I've got to come up with some explanations for why that might be. Well, one thing I can see about my video was that when I released the ball, I actually released it in front of the meter stick. And so objects in the foreground are going to appear bigger. Objects in the background are going to appear smaller. So if I were to drop the ball in front of the meter stick, which I did here, it will have appeared to have traveled a greater distance than it actually did, due to the way I calibrated the video. So this object appears to be traveling a greater distance in that given amount of time, because it's in front of the ruler, and that could explain why my numbers are higher than what I expected. Other things that I might have done is maybe I didn't accurately calibrate it, although I was pretty careful on that calibration, but that's about it.